Okay, welcome back, guys. Today we are going to look at this problem, which says that there is a beaver is swimming across the ocean, right? And here it aims to explore the Bermuda rectangle. So there is no Bermuda triangle; it's a Bermuda rectangle, right? Rectangle. Rectangle could be of this shape, square shape, this shape like this, right? Of course, it poses no danger to the beaver, but it is interesting from a scientific perspective. Unlike the Bermuda Triangle, not much is known about Bermuda Rectangle. Okay, then specifically, the beaver knows for sure that the area of the rectangle is S, right? Beaver knows for sure that the area of the rectangle is S. So there is a rectangle given, right? uh, Area of rectangle is S, right? Now its sides are integers like 1, 2, 3, 4 like that, right? And bottom left corner is located at 0.00, right? So you can think of it like this, that there is some here and here, right? This is 0 point and x, and left corner of this is here, right? Let me change the color, right? Yeah. So okay. So it can be like this, right? And area is equal to S, right? Okay. Now let's see here what happens is the beaver is interested in how many cells from a rectangle. Okay, beaver is still how many beaver is interested in how many cells from a rectangle with sides x comma y. So there is some other rectangle, right? Whose sides could be like x and y, like this, right? Okay, then whose left corner is at point 0, comma 0 can be located within the Bermuda rectangle. Okay, there is a Bermuda rectangle here, right? Now there should some rectangle, other rectangle whose side also 0, comma 0, whose sides left corner is in like this, right? Okay. Okay, within the Bermuda rectangle, a cell is very interested how many cells from a rectangle. Okay, so how many cells from so there is a rectangle will be given to us. From that rectangle, how many cells we can do this, right? Whose left corner can be located in the Bermuda rectangle. Okay, a cell is considered to be within the Bermuda rectangle if there is a rectangle is either given instead of the Bermuda rectangle and contains the cell. Help the viewer quickly respond to queries. Unit to answer key query. These tests concerned multiple test cases. First line contains a number of test cases. T. Description of the test. Area of Bermuda rectangle, number of queries. Okay, the followed queries Q each contains integer x comma y. Okay, it is guaranteed so the sum of Q over. Okay, so guys, look, I think the question here is uh, for us that we will be given some x comma y queries, right? And based on this x comma y, we have to find uh, the Bermuda triangle, right? Like if it is inside the Bermuda Triangle or not, and how many cells from this x comma y are inside the Bermuda Triangle, right? So if we have given some S area, right, of the rectangle, let's say x A cross B, right? And let's say 20 means 5 cross 4. Like this is 5, this is 5, this is 4, and this is 4. Let's say these are the dimensions of the Bermuda rectangle, right? But it could be 10 into 2 also, right? It could be 2 into 10 also because area is same for all of them, right? So for 20, what are the possible uh, multiplications, right? So if I go for prime factorization of 20 to 10 to 5, 5, it could be right, 4 into 5, it could be 2 into 10. These two possibilities are there, right? Then uh, because we are only given the area, right, of the rectangle, then we will get some queries of x comma y like this. Okay, let's say 2 comma 3. 2 is this, 3 this, 3, 3. 2, 2, 3 into 2, 6. 6 cells, right? There are 20 cells inside this here. There are 20 cells. But if this was like this, 10, what? 2 into 10 or 10 into 2, right? If it was like this, then how many cells would have been there? Like this, like this, right? If it is well like this, this is 2 and this is 10, then only 4 cells would have been inside the Bermuda rectangle, right? From this. So how will I find the description of the test, right? And then how can we like find that out? So we have given the area, right? But we don't know the exact dimensions of this Bermuda rectangle, right? Like the width and height of this, right? So it could be any pair of integers in that case, right? Okay, so what we can do, guys, is that we can map out all the Bermuda rectangles possible, right, inside this, right? If we can do this, then let's see if we can do, right? Okay, so let's say it was 20, right? S is equal to 20. So here it goes to 10 cross 2, 2 cross 10, width into height it is, right? And 4 cross 5, 5 cross 4, right? So this is how we can draw all of them. So 10 width and height is 2, right? So it could be like this here, right? Here, this one is 10 cross 2, and we can do similarly here also. 2 cross 10, right? It's 2 cross 10. Then we have 4 cross 5, right? 4 is width here, and 5 is the uh, here like this. 4 cross 5. This is 4 cross 5, and this could be 5 here 5 cross 4. Okay, it's 4 cross 5, and this is uh, opposite to this 5 cross 4, right? Now you see, we have like multiple Bermuda rectangles possible in this 20. If I have given this 20, right? I have superimposed every possible Bermuda rectangle configuration in our map, right? And all of their bottom left corner are at 0, comma 0, right? And now, uh, if I receive any query, right? Let's say 8 cross 8. There is some query 8 cross, let's say uh, 4 cross 8, let's say, right? If I received a query called uh, 4 cross 8 in this case, right? Now, and then I need to calculate that how many of 1 cross 1 grid square fall inside both the query area and the rectangle uh, superimposed staircase, like this, right? Like this, you can say this is staircase, right? So any of there it could be, you have to calculate that. So if I have this, right? If I have this for query q is equal to 4 cross 5, 4 is what? Uh, Width and height is 8, right? So like this here, okay, right? Yeah, okay. Here I have this query called 4 cross 8, right? So I have to calculate the how many grids like this grid, right? You can see like this part, right? And all of this part are inside. We can calculate. We I have to calculate this. So mathematically, let's the sort the divisors of S, right? Let's say divisor of S could be like D1, then D2, like DK, like this, right? Like we have 2, 4, 5, 10, like this. Or I can do only like this, 2, 2, 4, 5, or 2, 2, 5, like this, right? 2 to 5. So these represent uh, all the divisors of S, right? It could be 2, it could be 5, it could be 4, or let's say, okay, you see here that our 2, our 4, 5, 10, right? These are the divisors. So these are these represent our possible widths of S, right? 2, 4, 5, 10, like this. These are our possible widths. It can be 2, it can be 4, it can be 5, it can be 10. And vice versa, 2, 4, 5, 10, like this, right? So, and if these are our possible widths, then corresponding heights will be h of I is equal to, let's say this is our area S upon width di, right? Like this. So since the d is strictly increasing, right? Then 2, 4, 5, 10, like this increasing, right? Then h will be strictly decreasing also. Okay, what we can do, guys, is that we can assume this as a outer boundary of this our Bermuda Triangle area, right? Cells, rectangle cells. So we can so the outer boundary of this zone is a like piecewise decreasing function. Okay, where the maximum height, let's say maximum height ft, right, at any width ft, max height at any width between t of I minus 1, right, comma di is exactly hi, right? So the height of this function, piece, because this is piecewise function, right? If the width is decreasing from 2 to 4, increasing from 2 to 4, right? Then the maximum height is possibly 10 only, right? Here you can see here, right? That's why. So to find the number of overlapping squares, what we can do is we need to evaluate the area under this curve, right? And this will be kept by our query boundaries x and y. And so this is how it will map perfectly to integral, like the area is equal to 0 to x. X is a query width, right? Minimum of f of t comma y to dt, right? Because ft is strictly decreasing here, it will intersect our height cap y here at exactly one logical point, right? You can see here. Here, here it is intersecting at this point only, right? So we can find this pivot index v using binary search, right? Where v is the largest divisor index, such as d of v is equal to s of y, right? Uh, this gives us two clean scenarios here now. Right? One is fully submerged, and so our entire query width falls in the region where staircase is taller than y, right? And height is completely kept. Okay. So this, because this ft is strictly decreasing, right? Okay, then it will intersect our height cap y, right? Uh, at exactly one logical point, right? So ft is the like boundary function, right? Outer boundary function. Ft is hi, right? This is just a height function for given width t. For given width t, right? This is given x, right? Okay. Now this will intersect here. You, we can find this pivot index v using binary search. Okay. Where v is the largest divisor index such that d of v, like divisor v is less than or equal to s of divided by y. Correct. This is largest possible. Like 10, for 20 it is 10, right? We have to find the, this is width, right? If this represents width, this is the height, right? So like this. This gives us two clean scenarios now. One is fully submerged, right? Like fully submerged means that x is less than or equal to dv. So our entire query width falls in the region. This is one case where the staircase is taller than y and height is completely kept also. So the overlapping area is just a simple rectangle x cross y, right? If it is all inside it, right? If our query is always falls inside all of these uh, possibilities, then number of cells could be x cross y, right? But second thing is, second case could be x could be greater than dv, right? So the area starts at a capped rectangle would be like this dv cross y, but after dv, uh, the height of staircase drops below y, right? The rest of area is simply the sum of remaining stair set up to x. Okay, so we have to solve this. Right, we cannot afford to iterate through the steps every time. Right? We have like 300,000 queries something, so we don't want TLE error. So what we will do instead, we pre-calculate our uh, prefix some array. Okay, some array p of the area of every single stair step. Okay, this reduces the query time to order of logarithm of k. Okay, by grouping the sum of the required steps instantly. Right, so area is equal to dv dot y plus I is equal to v plus 1 to u di minus 1 dot hi, right, plus x minus du dot hu plus 1. The u for us is the index of the largest divisor, right, which is less than or equal to x. So let me code this for you, and we will look into it, right? Okay, I am opening the Visual Studio Code now. Then we will go to okay, so can you see this? No. So let me open up for you. Okay, now you can see this, right? Okay. This is our main, right? Now it's like has include a use stream right? S include. I need vector for prefixism and I need algorithm for sorting purposes, right? Using namespace standard, right? First, what I will have is my main function, right? Okay, it will be into main, right? iOS base at sync with whatever base sync with CDIO, artificial false, and cin.py null like this. Then number of test cases, right? And if cin like this, while t minus, we will call the function so, right? At the end of this, I can return 0, right? Here. And this is my solve function now here. Word solve. It will have a area of the rectangle, Bermuda rectangle S and number of queries, right? So, Q, right? First, we will find all the divisors of S, right? It's in square root of S time, okay? So first I will do a vector long long at temp here, and what I will do for long I is equal to 1, I cross I is less than equal to S plus right here, and if S modulo I is equal to 0, which means what? If it is dividing completely to S, right? Then what I will do is temp dot push back I. It's a divisor of S, right? And if I cross I is not equal to S, right? Then temp dot push back uh, S divided by I, right? Like let's say 4 is divisible by 5, right? Then 5 is also divisor uh, the of S, right? If it is not like square like 9 3 cross 3, we cannot like push back 3 one more than one time, right? So this is all the divisors I got. Then I have to sort them, right? Sort dot begin content, right? Right. So now I will set up a one indexed array for our math formula. What we had is vector long, right? D, right? And D dot push back, what? Push back 0. Why it is so? Because D0 is 0, right? because we have to set up the one index, right? Then for auto x and temp, whatever temp is, d dot to push back x, right? All the divisor will be pushed back inside this, right? Now what I will have is int k is equal to d dot size minus 1, because we want only one index. How many are there, right? Then width. Now I have to calculate the heights also, right? Vector long right height of k plus 2 comma 0, because I have to set this also at one index, right? And I have a prefix also, vector long p k plus 1 comma 0, right? Now we will pre-compute the heights and prefix sum of stair areas. Okay, so for integer I is equal to 1, I is less than equal to k, I plus plus, right? So it will be h of height will be s of divided by di, right? This will be height for us, and area of this uh, vi is equal to pi minus 1, right, plus the area of this, right? Di minus d of I minus 1 into hi, right? This is the area of the height into di and di minus 1, right? Like this. Then this is decreasing, right? So okay, prefix area for all the heights and widths, because first we are calculating height also, right? Widths are given already, and pi minus 1 is already 0 initialized here. Okay, here only we have prefix areas. Then h of k plus 1 equal to 0. So last is also 0, right? So this is the boundary condition for when x reach the max divisor. Now I will process the queries in a locate time using the binary search. Okay, so let me do this. While q minus minus, right, long x comma y, in x y like this. Then I will find v, which will be the largest index where the divisor is less than equal to s divided by y, right? So it will be long max d for y, let's write s divided by y here, and also v is equal to upper bound we have to find inside this, right, upper bound of this divisor, like this, right, max d for upper bound of this. Then this is the iterator for us. Then we will access this also, into v is equal to highest divisor, right, distance, right, d dot begin might be right minus 1. So this will get us the point where there's the point V, right? So distance means from this to this, what is the distance? That's how we can get the uh, like value of that, right? Then now if x is less than equal to d of v, right? This is a case one, right? Query width is entirely under the height cap, right? Then we can see out x cross y, right? Like this. If it is not the case, right? If it is not the case, then we have entered in the case 2 where the query width extends past the y cap into the staircase, right? So auto ITU is equal to upper bound, right? Not like this, upper bound here, d dot begin, comma, d dot end, comma x, right? Then MTU equal to distance, d dot begin, comma, at u minus 1, right? Then I will have long area equal to d of v into y, right? Then area is equal to prefix of u minus prefix of v, right? Then area is equal to x minus du, right? Into uh plus 1, see out area in this case. Now let me try to submit it also, right? Okay, so where we were here, I will choose my file, it's main.cpv, and I will try to submit it. Let's see, it's in the queue. Runtime error test 1, why it is oh, it's x minus du into okay. Let me do this again now. Okay, I will choose a file. Okay, again error. PU minus PV dV into Y. I think this time it should work. I think so. If it is not giving me runtime error or something like this, I have to choose my file from here and I'll submit it. Right. Okay, I will try to check what is the error we facing. Right. Rest here reading the next integer. Okay, something here is okay. Here it was like messing around, right? Okay. Alright. It was my friend and now I will submit it. Accepted as you can see here, guys, right? Okay. Next we can find some problems on this. There is a very good website called CP algorithms, right? Here we can find good problems, practice problems and all right. On dynamic programming, bottom-up dynamic programming, classic dynamic problems like this. So we can practice many things here, right? So if I go and if I am trying to do, and there is one more website called CSES, I think here. Yes, I am going to insert this. Okay, here I am finding it. Okay, all right. You see, there are many problems I have already done, but I am going to practice more problems. So where I have to go here, problem set. Here sorting is searching. It is dynamic programming. Okay, graph I have already done. Wow, I don't know this. Range queries, range from some query. Okay, tree algorithms, mathematics, string algorithms, geometry. Okay, so what I will do is meet in the middle, aiming distance. Okay, sliding window problems, then only little bit. Interactive, bitwise operations, construction problems, advanced graph problems, counting problems, additional problems, problems 2. Okay, there is a good number of problems, right? Uh, so from this, what I will do, I will take this problem one by one and we will try to do these, right? This is the dice first problem set. Dice combination. Okay. So problem here, guys, is let's see.
क्या नाम है आपका? मेरा नाम चंचल।
Right, so just read the question. Your task is to count the number of ways to construct some n by throwing a dice one or more times. Right, so there is will we have been given some, right, some n is sum is equal to n. We have to throw a dice one or more times. Each throw produces an outcome from between 1 and 6. So we have to count the number of these, right? You see, let's say sum is 5, right? So we can do 1, 1 plus 1 plus 1 plus 1 like this. We can merge this like 1 plus 1 plus 1 is 2, right? And we can do this 1 plus 2 plus 2 like this. And we can do this 1 plus 3 plus 1 like this also, right? 1 plus 4 also, and direct 5 also, right? And one thing is 3 plus 2 also, right? So we can do like this. Uh, so how can we count these bees, guys, right? That's the question. Because we cannot do like so first approach could be like greedy, right? Like this. Uh, we take for 1, then we take for 2, right? We take for 3, like this. So what can we do is we have 5, we subtract 1 from this. This becomes 4, then again 1, this one 3, again 1, 2, again 1, 1, right? 1, 0. So this is one way we can achieve 0, like, right? And what we can do is we can branch it out, right? Like 5, we can subtract like how many ways? 6 ways, 1, 2, 3, 4, 5, and 6 ways. We can subtract 6 to know. We can subtract 5, we can subtract 1, we can subtract 2, 3, and 4. For this, it's valid. For 1, we can again do 1, 2, 3. Whoever will get us 0 as as answers, right? Then that's a valid way, right? That's a valid way. But the problem here is in this guys is that 1 comma 2 and 2 comma 1, these both are same, but by this case we are counting them as different, right? So this is not valid. Okay, so what we can do, uh, there is a function, I think yes, I am remembering that function from mathematics. uh, that this h of n is equal to h of 1, no, n minus 1 plus h of n minus 2, h of n minus 3, like this till 6, right? Plus h of n minus 4, h of n minus 5, h of n minus 6, right? If h0 will be 1, that's the case, right? And if it is but I think it's the same counting again, isn't it? It's like these both are similar, right? Yeah, these both are similar. Then how can we approach this problem? Do you have any idea, guys? Let's read the question again. Then I think we can find some four ways: one plus one plus one, one plus two, two plus one. Oh, so it's like different. It can count different also, right? Like two plus one and one plus two. They are counting both. Okay. So it's simple now. We can count that very simply, right? Uh, what we can do is, okay, only input that line as integer n. Okay, so this was our integer. Let me do is one thing. Has include IO string for our IO case, right? And I think I need vector also. Vectors using name space here, and main function will be like this: entity if cnt, right? We will have cnt and test whatever the value int n, right? Okay, there is nothing fancy here, no test case. So these are n, c, n, and we have to return that, right? So we will call a function, right? Uh, answer is equal to f of n minus 1 plus f of n minus 2 plus f of s3, right? 5 and plus f of n minus 6. Okay, right. Then this function will be integer f and n. If n is less than 0, return 0, and if n is equal to 0, in this case return 1, right? Else return same thing, right? Like this. So I think it will give us the answer, right? Okay, okay, and at the end return 0, right? Like this. Input will be, let's say I have an input called 4 is the sum, right? As the given is it in the example also. 3, right? Let me give it 3. And I am checking if my main dots where it is. Where is the error? Is there any error in this? What is the problem? Expected A here, okay. Plus, okay. Now it's good. Okay. Then in the terminal, I will have a G plus plus main dot cpp and get content dot txt, right? Uh, main. Oh, sorry. I think I G plus main dot cpp or main. Then I think run this. Whatever. I don't know how to run this, but let me check if where I am doing my things wrong. It will tell me what the compartment is being plugged into a program versus it. Right? So it was running fine yesterday, guys. What happened? Uh, okay, let me just try to submit it directly. Okay, we will look into it later. Where is this? Yes. Let me try to submit it. Right. Let's choose my file. main.cpp okay, so you can see the solution is expected accepted, but on the other cases it's giving us TLE, right? So it is asking us to optimize the code, right? So how can we do that? We can have a like initialized and vector, right, of size n, I think. Vector int dp of size n plus 1, I think, from 0, right? Where is n? Here it is, right? And what we can do is we just try to have a for loop, right? We just need a for loop, then we can get n out of it. Okay, for int I equal to 1, right? Okay, so 0 or like 1, I less than equal to n less plus, right? And dp of I is equal to dp of I minus 1. So I have to write some conditions, right? If I okay, so if I equal to 1, dp of I is equal to 1, right? Whereas if I think, yeah, this is the correct condition. If I is equal to 2, 2, 4, 8, 32, then this is the right case, right? And here, right? Okay, I don't need this now, right? And then I will try to resubmit it again, right? Let me go here and choose the file main.cpp and try to submit it. And checking ready here. Wrong answer it is giving. Okay. For many of it is okay, right? Is equal to dp of dp of 0. I think it should be 1, right? dp of this and dp of this, right? And this dp of 0, I think is equal to, it should be 1 initialized, right? Now it should give us the right answer. Right, let's try to submit. I will choose the file here and main.cpp and try to submit it. Right, what happened? Again, it's having the same thing, right? Let me choose the file and this will be main.cpp and try to submit it. Again, same thing, right? Why it is so? Answer is equal to I think dp of n, right? And not like that. Okay. Uh, Now I think it can go like this and let's see. Okay, now this wrong answers. Okay, so I think there is something missing in the problem. What is the task? So constraint n could be 10 to the power 6. So if we like sum that up, print the number of ways modulo this. Alright, so what I can do guys is first of all I can take instead of int I can take it as long, right? Long and yeah, yeah and one more thing I can do is const long mod equal to 10 to the power 1 e9 less 7, right here, right? Now I whenever I do these things, right, here I can choose this also uh, modulo mode. If I answer this again and try to submit it again, then I can I think pass the cases. But I am like more confident for this case. You can see it's accepted and it's running, right? It's a very good question and very beginner friendly also, right? This is first problem. It's done. Then what I will do, this is the second problem we will do called or not do not take this from dynamic programming, right? What we will do is we will take from the graph problem. Right, so DP we have done from DP one portion from DP, right? Now we will do the graph problem, right? Let's do this. Okay, you are given a map of building and your task is to count the number of its rooms. Just a second. So you are given a map of a building, and your task is to count the number of its rooms. Okay, size of the map is n cross m squares, and each square is either a floor or a wall. Okay, so you can walk left, right, up, and down through the floor squares. First input has the line 26 n cross n and the height and width of the map. There is a n lines of m characters. Each character is either floor or a wall, has wall, right? So we have to count the rooms, right? So room is like the which has four sides of walls, right? Okay, so that's the room. So guys, I think to solve this, it's a very easy question. I think because let's say this is our question, right? Here, here, and we took it here now, right? If this I am in some dot, right? How many dots I can visit from that? I make them visit it and count that, right? If it is some hash, we will ignore it, right? We will not go for it, right? Then, okay, I think I am ready to code this. How we can do this is, I think I need vector for this also, and as include I use string here, as include vector, and again if we using space std here, and uh, what is the question? Input. First input line has two integers n cross m. Okay. Height and width of the map. There are n lines of characters for each character. Okay, so I have to take this input also. Okay, so and to name int n cross m same n here, right? And one thing I will do is I will have a vector like map, right? Also vector of integer, not of integer, like character, or like map. I can say it is like map and comma vector of char n, right? So right. Then what I can do is I will take the input inside it, right? for int I equal to 0 less than n I plus plus for int j equal to 0 j less than n plus plus c in map I comma j. So we have the map also, right? Now okay, so I think we can call DFS for this, right? First of all, I should have a widgeted array if it is already widgeted or not, right? So vector of so bool also we can create a bool widgeted and cross vector of bool and cross false, right? Uh, what we can have then? We will go from 0 to 0, right? For int I equal to 0, I less than n, I plus plus. For int j equal to 0, j is less than n, j plus plus. Right? If not widgeted of I comma j, then I have to perform DFS for this, right? So I have a function called DFS. It will take I integer j and map our node right vector of care and program that and our widgeted thing that bool ampersand widgeted. Okay, then widgeted will be true first of all. So if I comma j equal to true. Wait, don't why it is like giving me hints? I don't understand it. Can I stop it somehow? Alright, whatever we will. So it's widgeted. Now I have to check its neighbors, right? So first of all, what I have like dx dy things, right? I can go up down like this, right? So whatever vector dx is equal to minus 1 comma 0 comma 1 comma 0, right? Vector dy is equal to minus 1 comma 0 comma 1 comma 0 comma minus 1, like this, right? Okay, right, it's now like this. So I have to move check the adjacent for int I equal to 0, I less than 4, 4 I plus plus like this. And then how you can say new x also. New x is I plus di and new y I plus dy j plus dy. Okay. Then if new x is greater than 0 and new x is less than size, and okay, if we are in our boundaries, right, and not visited one first of all, and Map not one. I think it should be a floor, right? Floor like this. Dot only, right? Dot character. Then DFS is like this. And one more thing, not visited. And one more thing is, and yeah, that's the case, right? Like map visited, and it should be M, right? In that case, what we can do is we can do count plus plus uh, and count equal to 0 and see out count and return 0, right? And I think it's a workable code for this. Let's try to submit it. Right, I will choose my file, man.cpp, and try to submit it. Also, it's giving many wrong answers, but it's also accepted somehow. I will play, but many wrong answers are there, right? What is a wall and what is a task area? One, two, three. Alright. I think I have this correct solution, but I don't know why it's giving me wrong answers. Right? What is the problem in the solution? Let me check. Here. Row coded parameter I, however, you also used I as the loop counter to iterate through four directions. DFS ij and less. Okay, so this is ij here. What I have to do? I should go for k, right? Was that the only thing I missed? Quantum is right. Changed it, and now let me see if I can submit it and pass the test cases. It's accepted, guys. Okay, and yeah, that's it. We are doing questions one by one, and it's very good problems also here. And we will see what happens from now, right? Thank you so much, guys, for watching, and we will meet you again somewhere in the shadows.